So here we're asked, what is the magnitude of the cross product A cross B? So A cross B. And we're by putting the arrow on top of each variable, we're classifying these as vectors. So for each vector in a 3D plane, there's three components. There's the x, y, and z. So we can define this for each component. So we have A is equal to, we have A1, this is the magnitude, and then the direction. I is in the x direction, plus A2 times j, which is the y direction, plus A3 times k. So we split up the vector A into its three components in the x, y, and z direction on a 3D plane. And we'll do the same for B. So B equals B1, I plus B2, J plus B3, B3K, not J. So these are kind of the separate components for each vector. And this will help us figure out the equation for the cross product. So here we'll do A cross B. A nice way to look at this is to draw the following. So we'll have I, J, K, and we'll have A1, A2, A3, and then B1, B2, B3. So putting it in this kind of matrix will help us derive the formula for kind of the magnitude. So to start off, to look at each component, so we want to solve for each component of the cross product, the I component, the J component, and the K component. So we know here, let me just erase this, so we'll move the equal sign down here, so equals. So when we're calculating for the I component, what we want to do here is we cover up this, or let me rephrase that. We would look at only this part. So we don't look at the column I. We only look at whatever else is not in column I. So looking at just what's not in column I, so we have A2, B2, A3, and B3. So to calculate the I component, it's basically the cross. So A2, sorry, let me redo that. So A2 times B3 minus B2 times A3. So just thinking about it as a cross, that'll help you derive the equation. So here we have the first component, A2 times B3 minus, we have B2 times A3. Okay, I'm just going to double check something really quick. Good. We're just double checking that we are on the right track. So here we have the I component, and then we do the same thing for J and K. So in scenario J, we ignore the J column. So we're going to ignore this column. And we're only going to look at, I'll highlight them in red. So we're only going to look at this column and this column. And what we're going to do, we're going to do the cross. So A1 times B3 minus B1 times A3. So we'll write that out. So we have A1 times B3 minus B1 times A3 is J. So that's the J component right there. And now we have the K component, so the component of the vector in the Z direction. So we do the exact same thing again. We ignore the K column and we only look at everything else essentially, except for the K column. And we do the cross, so we'll do A1 times B2 minus B1 times A2. So I'll write that out. So we said A1 times B2 minus B1 times A2, sorry. So now we've defined each component of the cross product in terms of A and B, in terms of the two vectors that we're using to complete the cross product. And then here I'm going to erase the top of the board, but we just really need the bottom section here to derive the magnitude. So the magnitude of the cross product here so the straight lines on each side is reference to the magnitude, is basically the square root. So the magnitude of the x component squared, so I'll represent that with, I'll just say, so we're talking about the magnitude of the x component squared plus the magnitude of the y component squared plus the magnitude of the z component squared. Okay, so this is just the basic magnitude formula where we have the square root of each component squared. So I'll erase what's in there and we'll fill that out based on what we've calculated here. So this is all underneath the square root. I'll put it in a large bracket. So the first part is A2 B3 minus B2 A3. And this is the first component squared. And then we add on A1 B3 minus B1 A3 squared. And then we add on A1 B2 minus B1 A2 squared. So I essentially just took the x component here and used it up here and squared it, and then the y component here and used it up here and squared it, and then the z component here and used it up here and squared it. And then this equation right here, this equation gives us the magnitude. So you don't see the top portion because of my face, so let me see if I can drag this down. Okay. So I don't think you see the first portion. So the missing portion, I'll just write it out. So it's just the first term, this term, I'll just write it out down here, is A2 B3 minus B2 A3 squared. So that's just the first line up there, and then the rest is visible on the screen. And that's essentially the formula for the magnitude of the cross product. So here we can see they followed this similar idea, and we just kind of gave you a further explanation of how to derive that formula. Okay, so here the solution is correct.